So good morning, sir. This is my video presentation of the device that converts AC to DC current. So let's start. So what is AC or DC power supply? So an alternating current or AC is an electrical current whose magnitude and direction vary cyclically, as opposed to direct current or DC, or continuous current whose direction remains constant. The usual waveform of an AC is a sine wave, as the result in the most efficient transmission of energy. However, in certain applications, different waveforms are used, such as triangular or square waves. So, what's the difference about AC and DC? In 1887, direct current or DC was a king. At the time, there were 121 Edison power stations scattered across the United States, delivering DC electricity to its customers. But DC had a great limitation, namely, that power plants could only send DC electricity about a mile before the electricity began to lose power. So, when George Westinghouse introduced his system-based high-voltage alternating current or AC, which could carry electricity hundreds of miles with a little loss of power, people naturally took notice. A battle of the currents ensued. In the end, Westinghouse AC prevailed. So, what is the device that converts AC to DC? The device that converts AC to DC is a rectifier. So, a rectifier is an electrical device that converts alternating current, which periodically reverses direction, to direct current or DC, which flows only in one direction. Rectifiers can take a wide variety of physical forms: vacuum tube, diodes, and crystal radio receivers, to modern silicon-based designs. There are different types of rectifiers. The first one is an uncontrolled rectifier. When a diode is connected to a rectifier in any configuration, the rectifier cannot complete under the control of an operator, which is known as uncontrolled rectifiers. It does not let the power change based on the requirement of the load. So this kind of rectifier is normally used in fixed or stable power supplies. This kind of rectifier simply uses diodes and provides stable output voltage based on the input of AC only. The another one is full wave rectifier. This rectifier, during both the half cycles when AC power supply is applied to the flows of the current through the load, flows in the same direction. This circuit yields a higher standard output voltage by alternating both polarities, waveform of pulsating DC. This sort of rectification can be achieved by the using of latest two crystal diodes conducting current differently. The next one is bridge rectifier. A bridge rectifier circuit can be built with four diodes, which are used to change the both input half cycle to DC output. So, in this kind of rectifier, the four diodes are mainly connected in exact form. The full wave rectifier's output includes fewer ripples as compared to the half wave rectifier, although it's not level and stable to make the out voltage level. Capacitor is used at the circuit. The charge and discharge of the capacitor will make level transition among these half cycle. The next is center tap full wave rectifier. This type of rectifier circuit uses transformer with secondary winding tapped at the center point. Two diodes are connected in the circuit so that each one of them uses one of half cycle in the AC voltage. For rectification, one diode uses the AC voltage showing the upper half of the secondary winding. The efficiency of this circuit are high because the AC supply brings power throughout both hubs. The, the last example is full wave bridge rectifier. A bridge rectifier circuit is one of the capable forms of full wave rectifier that uses four diodes in a bridge topology. in place of the center top transformer. A normal transformer is used. The AC supply is to be rectified is applied to the diagonal differing ends of the bridge, and the load of resistor connected across the residual two diagonal differing of the bridge. So what are the equipments used to convert AC to DC? The first one is transformer. In a power supply system that converts AC to DC, the transformer will function just as they would in any other system, transmitting and converting energy between high and low. The next one is diode. Diode is a two-terminal electronic component that conducts current primarily in one direction. It has low resistance in one direction and high resistance in the other. The next is capacitor. The capacitor is a device that stores electrical energy in an electrical field. It is a passive electronic component with two terminals. So how conversion works? AC to DC converters takes the AC power from wall outlet and converts it to unregulated DC. This power supply includes transformers that change the voltage of the AC that comes through wall outlets, rectifiers to save it from AC to DC, and a filter that removes noises from the peaks and troughs of the AC power waves. Typically, the voltage will be stepped down by the transformer to the voltage required by the device being supplied. In the first step of converting AC to DC, the voltage is rectified using series of diodes. This transforms the sinusoidal AC wave into a series of positive peaks using a rectifier. At this point, however, there is still waveform fluctuation the time between the peaks that needs to be removed. To filter this output, a capacitor is used by creating a reservoir of energy that is applied to the load when its voltage drops. The capacitor stores incoming energy on the rising edge and expands when the voltage drops. Generally, the higher the storage capacity of the capacitor, the higher the quality of the power supply. After voltage conversion, output variation is smooth output by passing the voltage through a regulator to create a fixed DC output. So that's it. Thank you.